Hi, this is Ilya, awesome designer, and I welcome you to the second part of From Zero to Azure and on how to become a cloud developer, thoughts to code. So before we start with the second part, I want quickly to recapitulate what you have learned so far in the last part. You learned about the three main qualities every aspiring developer should work on, which are imagination, abstraction, and logic. If you not have seen the first part, please return to my YouTube channel and watch that so that you can keep up with us, okay? Thank you. And here's what you will learn today. Visualize first and run later. So this is a philosophy we have followed already in the first part, and now we put that thing into practice, okay? And to do that, you will learn about pseudocode, what pseudocode is, what it looks like. You will learn about flowchart diagrams, what flowchart diagrams are, and how to use them to visualize your code, to visualize the problem you want to solve. And you will learn about Nassi-Shneiderman diagrams. They are very similar to flowcharts. They have a different notation or way and they look very different, but they are very similar. And Nassi-Shneiderman diagrams are better for beginners to realize really how a process or how a real-world problem is broken down into different small units of work. This is what a flowchart diagram cannot do directly. Okay. So let's see what pseudocode looks like. You can see, and please don't be afraid of this little bit of code here. You don't have to remember that or something else. It's just to show you how a piece of pseudocode actually looks like. You can see this little piece of pseudocode, which I have copied from Wikipedia, and you can see in this line that it's mainly formulated in natural language. This means it is not formulated, for example, as a real if statement. But there is something like, if I is divisible by 3, print with fizz, okay? This is not a real statement, a C statement. It's just for you to write down the solution to the problem, to the real world problem you want to solve, and to visualize it before you actually create the code, okay? And this is what I call sketching your idea on a high level. So all the different diagrams we are talking about, 2 of them, they do really the same thing, except that you have shapes and colors and everything else. And pseudocode is like some sort of code, but not the real code that a computer can execute as a program, okay? So here you can see a sample of a Nassi-Shneiderman diagram. And this diagram type lets you visualize code using different graphical elements. So if you take a look at the sample, you can see an entry, the open web browser entry. And this type of entry, this rectangle, is called instruction. And instructions tell the computer what to do. For example, open the web browser or print a specific message to the screen. And this is defined as a step within a process, okay? And the next line, the colored light blue line is called an if statement. So this is where we make decisions within our code and where your basic knowledge, the things you already learned about logical operations, comes into play. In this sample, the condition that is checked to be true or false is the statement if Wikipedia was loaded within the web browser that was opened before. And on the left-hand side, colored in green, you can see which instruction needs to be executed if the condition is true. That would be a search for an article, for example. And you can see that the search for an article, again, is another instruction. But this time it is placed within the if statement. Okay? And the opposite case, meaning that the condition is false, is triggering the click Wikipedia link instruction. Okay? And this is again an instruction, but it's placed on the right hand side, and this is where you write down the instructions if the condition is not true. So, as a general rule of thumb, you can say that within a Nassi-Shneiderman diagram, if you have a condition, the true statement is on the left side and the false statement is on the right side. This diagram type was standardized in Germany, I don't know exactly when, but I think about 1990 or something, but it is not standardized in, it's not standardized all over the world, okay? But it has specific rules we will follow, and you will see later when we use the app to create, or our tool to create the Nassi-Shneiderman diagrams, that this tool is following also specific rules, okay? And it was developed by Isaac Nassi and Ben Snyderman in 1972. And that's quite a long time, and it's still used out there. So the next diagram type I like to show you is the flowchart diagram. You should feel comfortable with this kind of diagram because it's widely spread and used for many types of things. It's not used only in programming, but it's also used in economics, for example, or it is used in production, in companies and so on, to visualize processes and so on. But we will use it again in the same way we use the pseudocode and the Nassi-Shneiderman diagrams, just to visualize our code. And it is really very similar to the Nassi-Shneiderman diagrams, but it is not as good as the Nassi-Shneiderman diagram to really visualize the elements. It's a bit different, so you can see that I use the same colors like in a Nassi-Shneiderman diagram. That way you can compare both diagram types very easily. But within a flowchart diagram, instructions are called mainly operations. The if statement is called decision. This part here. That's a light blue romp you can see. Again, I have placed the true branch on the left hand side. You can see the true branch here and the false branch on the right hand side, okay? If you choose to do it another way, feel free to do it. But I would recommend that you take this path and you create some small rule set for yourself just until you feel really secure with the diagram types. I like to welcome you now to your first exercise. In this first exercise, I want you to visualize the process of how to start an automatic car. Okay? Which steps are really necessary to start an automatic car? I really want you to pause the video now and to think about it for a few minutes. Welcome back, and I like to show you my sample approach that I have used. So these are the steps that I have visualized, and It includes if you have the keys. If you don't have the keys, go and get them. Unlock the door, and was the unlocking of the door successful or not? If not, maybe you have the wrong key, or if you have the wrong key, go and get the right one, then return to your car. And if the key is not there, this is the end of your program, because you are unable to start the car in a legal way. If successful, sit in the car, fasten your seatbelts, ensure the lever is in position P for parking, put the key into the steering lock of the car and turn the key for about 180 degrees away from you. If the engine was started successfully, the program is done. If not, retry it. This is an exhaustive version on how to turn on an automatic car, but it demonstrates quite well how a real-world problem is broken down into several steps. This is often called a top-down approach. I like to introduce you now to the two apps or the tools that we will use. The first tool is Structurizer, and with this tool we will create actually Nassi-Shneiderman diagrams. And the second tool is Dia, and we will use that tool to create flowchart diagrams. Okay? Both tools are free and open source, and if you go to my blog, you can read about the blog address in the description of this video. You can download the script or the book that's accompanying this series, and you can find the download links there. If not, just fire up your favorite browser and your favorite search engine and search for Structurizer and Dia. If you want to install Structurizer on your PC, you first have to install Java Runtime, and then you install Structurizer, okay? When you are done, please return, because we will start then with the actual practical part with a demo, where I will show you how to create a Nassi-Shneiderman diagram using Structurizer, and I will show you how to create a flowchart using Dia. Let's start with a quick overview of the Structurizer UI. Structurizer actually has a very simple UI. After some trial and error, you will get the concept very fast. And I'm going to explain you the UI very quickly, and we will move on. So here you have actually the diagramming surface. You have in this part of the toolbar the instructions that will be inserted before the current statement, and the instructions here that will be inserted after the current statement. Here you see the color palette, and these two buttons are used to increase or decrease the font. When you hover over the elements, you can see that the tooltip is shown explaining each element in detail. So we will use only a few elements, and we will use them continuously and repeatedly so that you will learn very quickly how to use them. Okay? Okay, let's actually create your first Nassi-Shneiderman diagram. To add a title, simply double click the 3 question marks here and enter the title. How to start an automatic car, and a comment. This is the first exercise, and click OK. So you don't have to add a comment, I have added it, and you will see later on for what it is useful. For now, just double click the first statement here, and every program needs a start. So does this one, and we indicate it by typing in start into the first text box, and we add again a comment. Our application is actually starting, and we click OK. Now we have the first decision to add, and the first question here is, do you have the keys? And to do that, we need to add an if statement, okay? And we want to add the if statement right after the first element here. So we click on Start and select Insert a new if statement after the selected element. Simply type in this question: do you have the keys? Check if we have the keys. And click on OK. And you see Structurizer has inserted if statement. You see on the left hand side the true part, and on the right hand side the false part. So if we don't have the keys, we need to go and get them. And if we have the keys, we can actually try to unlock the door. And if unlocking the door was successful, which we need to test, this means an additional if statement. So you can see that this if statement was inserted right under the last statement we had within the first if statement. And if unlocking the door was successful, we can actually enter the car. And if that was not successful, I think that we got maybe the wrong key. So go and get the right key. Now we need to check if we actually have the right keys. And for this we need another if statement. If so, enter the car. If this is the wrong key, our program is at its end, because we have no possibility to enter the car on a legal way. So after that was done, and we have successfully entered our car, we need to fasten our seat belts. Okay, this is the next instruction. And then we need to put the key into the steering lock of the car. After we have done that, we need to turn the key 180 degrees away from us, okay, to actually start the car. And now we need to check again if the car has started successfully. This means we need another if statement. If yes, our program is done. And if not, we have to retry once, and that's it. As you can see, we have created very quickly the Nassi-Snyder diagram to visualize the problem we want to solve. And it took only a few minutes. I've used only two elements. The first element is the instruction element, and the second element is the if-then element. That's basically it. It's not very complicated, and this is all we need for now. Later on we will do more, and I will show you quickly how to colorize the different elements. So we have an instruction, and we have colored these instructions until now with yellow, and we have colored the if statements with a light blue, and we have colored the true part of the if statements always with a green color, and the false part, yeah, with a cyan color. Okay, so we do that quickly and color everything. See, true, green, 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 false. Then we have again an if, and the green part, and the false part again, and again an if, successful, unsuccessful. Okay. Oh, let's do that again. Good. And you can see now why the colors are so useful. They will show us every single statement, and they will show us also the structure. Nice. Now let's save this work. I really like to encourage you to try and to work a little bit more with Structurizer, maybe using your own little exercise. Just try it out, play a bit with it, and you will see you can really quickly create Nassi-Snyder diagrams using Structurizer to project your thoughts into code, okay? The last thing I want to show you regarding Structurizer is it's actually the feature that Structurizer has to export code, and in our case we will use C# later on in this course to export the pseudocode. Well, let's open the file, and you can see that there was already some code created. Let me format that a little bit. You can do the following. You can put the code window here side by side with Structurizer just to compare a little bit the kind of statements that have been generated and what this code actually looks like. But please, there's no need that you understand the code now. It's only to show you how or what pseudocode looks like. You can see here that we have our start instruction here. This is indicated here. And the first if. If, do you have the keys? Then unlock the door. Unlock the door was successful. Yes. Enter the car. And all the other things. And if not, go and get the right key. Let me give you now a quick overview of the DIY. So what you can see here are the tools. In this part here, you can see the shapes actually. And this is the canvas where you will draw your diagram. During our dia session, we will only use 3 elements. This is the first element is the process element. Just click it and draw it here on the canvas. And the second element is the decision element. Just click and draw. Okay. What we will use from the toolbar is the connector element. Those are basically the elements that we will use to create the diagram. I will show you now the first few steps. But I like to encourage you to finish the diagram on your own. And let's start by inserting the first process here. Let's call that again start. The first thing we need to do is to check if we have the keys. We insert a new if statement here. Do you have the keys? And in this case, we will place also the false value on the right side. Go and get the keys. And the true value on the left side, which is unlock the door. Now to connect these elements, simply click on the simple connector here on the line. And you see these little crosses that are placed on the line of each element. Click one of them and connect to another cross on the element you want to connect to. I do that again here just to show you how it works. And again, so if you have chosen by incident the wrong connection point, you can very easily change that. Just select it again and change the connection point. That's it in general, and you don't need more elements to do that. I can show you quickly again how to colorize the elements. You can, if you double click an element, I do that again, the properties box will open, and here you can see the fill color. Just select the fill color and click on apply. Okay? And what we have done, we have applied here a light blue for if statements. This one, okay. And the color green for the true part. And the color cyan or something similar, because not all colors are the same within the apps. This, yeah, light red part. Okay, I hope you now have an idea how you can use Structurize idea to visualize the different parts of your problem solution using Structurizer. Thanks for watching and see you in the next part.